So you are welcome to this concluding part of projectile motion. Term projectile motion part 3. In this video, we are going to dive into two cases. The first one is the motion of an object which is projected horizontally from the top of the tower. The second case under part 3 of our projectile motion is the motion of an object projected vertically upward from the top of the tower at an angle of theta to the horizontal. And class, in this first case, we are going to take a special look at a special case which we call relationship between h and r, where this h is the height of the tower from where the body is what now projected, and this r is the horizontal distance covered, which we call the range. So without wasting our time, let's dive into the video proper. The first one, case one. Case one. So let's go case one class. Case one. Now, looking at this diagram, we have a tower like this. This is our tower of height what now? H. A body is now projected horizontally like this. Okay? From the top of this tower, then it will move in this direction. Move. When it gets to this place, it will come down in this part. Are you with me? So from here to here, from here to here is what we call the horizontal distance covered by the body, which is the range. This place to this place is the height of the tower. Are you with me? Is the height of the tower. And this point is our view of what now? Of x, which is the horizontal, initial horizontal what now? Velocity. And the point of projection, the vertical initial velocity is equal to 0. So, which implies at the point of projection, our u of y equals to 0. So if they ask us, the only velocity that a projectile will have at the point of this projection for horizontal one is the what now? Initial component of the velocity. At any time t, the body will have both horizontal component and vertical component at any time t. At time t equals to 0 plus, the only velocity is u of x. But at any time t, time t means after the body has what now? Projected. The body will have what now? The two components of its velocity. Horizontal and what now? Vertical. Now, class, if you look at this diagram, here at the point of projection, our u of x is present. At any time t of projection, our u of x is what now? The same thing. So our horizontal initial velocity is the same throughout the motion. Why? The reason is what now? Not far-fetched. Because the only force that will make a body to change its position, which is the force of gravity, is only acting what now? On this body downward. It acts vertically what now? Downward. It does not act in what now? Horizontal what now? Direction. That force, okay, which we call what now? Force of gravity, that will make a body to change its position, is only acting downward. It does not act in what now? Horizontal what now? Direction. That is the reason why the initial horizontal component of the velocity is constant throughout the what now? The motion. So here we have our v here, which is the speed of landing, or the speed with which the body will strike the ground. So class, let us go. From this diagram, what they will ask us to calculate is the time the body will spend from this place to this place. So suppose I label this point what now? Point A. I label this point what now? Point B. And I label this point what now? Point C. Now class, take note of this. the time the body will spend from this point A to point B is the same as the time the body will spend from point A to point C, neglecting air resistance. I repeat, the time the body will take from A to B, okay, is the same as the time the body will take from A to C. What is the condition? Resistance is what now? Negligible. Negligible. Right? So we neglect what now? Yes, and that's the only condition that will make our time from A to B to be the same as what now? A to C. So let's get the time to take the body from A to C. Recall that we have our what now? Our S, which is the what now? Displacement or the distance, is equal to UT plus or minus RAT squared. Remove this sign first. Now, this is one of the what now? Equations of what now? Motion. Our S is just what now? UT plus RAT squared. If we are describing this motion, the motion is what now? In the vertical what now? Manner. So this one here, this S becomes what now? H equals to, because it's in the what now? Or vertical manner. Sorry, it's in vertical manner. This one will become what now? U of y t, then plus half A of y t what now? T squared. Now recall, we said our U of y equals to what now? 0. So it implies our H will be equals to 0 times t. Now, our A of y is the what now? Acceleration of what now? Due to gravity. And because the body is coming down, it will be positive. So here we have our A of y equals to what now? Plus g. Because the body is coming down, it is moving with gravity. It's coming down. So our what? A of y will be equal to what now? G. So this equation becomes plus gt squared. So what's the next in class? Take note of this. It means our h will be equals to what now? Gt squared. So this is the formula, okay, and it's used to calculate what now? The height of the tower. Height of the tower or height above the ground. But what we want to calculate is what now? The time if you take the body from what? From A to B. So from here, this T is the time from A to B. Now that means, cross multiply, we have our GT squared equals to what now? 2H. When I cross multiply, 2 times H, 2H. 1 times DT squared, DT squared. So divided by what now? By G. Our T squared equals to what now? 2H all over G. So make T separate formula. Ordinary T will now be equals to what? The root of 2H all over G. Where this T is the time to take the body from A to B, which is equally the total time spent by the body in the course of its work motion. And I told you that from A to B is the same as that from what now? A to C. So what this? Let us call this equation what now? Equation 1. Call this equation 1 and call this equation 2. All these things in block form, they are very important. Then the next thing that can also calculate here is what we call what now? The range. You can also calculate the range. What is range? Mathematical definition of range is what now? The product of the horizontal velocity and the time of flight. And mind you, the time of flight is from A to B. Are you with me? Which is this small what now? This small t. It's not all cases that we use big T for time of flight. It depends on the what now? The one we are describing. The one we are describing here is from A to B. And we use this T for time of flight, which is total time spent by the body during the course of its mission. So let us go. Range mathematically. This place is okay. So let me use this place. Range, mathematically, range is equals to what now? The product of the horizontal component of the velocity and the time of flight. Take note of this formula. It's a special formula. Okay? What is range? Range is u of x times t, meaning horizontal component. Let me put it here. Range is equals to what now? Horizontal velocity. Don't forget, please. Horizontal what now? Velocity, okay, times time of flight. What is time of flight? Total time spent by a projectile during the course of his what now? Of his mission. So from this place now, I have it like this. Okay? But recall that our t is root of what now? 2h over g. So change this, we have our r, which is range, equals what now? Ux, then root of 2h all over g. This is the formula that we are going to use to calculate what now? The range under this case 1. A body, you can say a body dropped from a height, okay? Or a body projected from what now? From the top of the tower or a building. Are you with me? That's the what now. Equation what now? All these equations are very important, like I said. The first one is h is what now? Height of the tower. Then this t is the total time spent by the body during the course of its motion. Then r is what now? The horizontal distance covered. Then what's that square case I said? Relationship between what now? H and r. Now look at this class. I want to get a formula that relates the height of the tower and the horizontal distance covered. I will use this equation. And this is what? This equation. Now, from equation what? Equation 3. I want to get the formula that connects R and H. From equation 3, let me wipe this things off. Pause the video, write them down, because I want to wipe them off. Let me just relax. Are you done writing? So, look at this. This is all plenty question. Look at this. From equation 3, if I want to remove this root, I will square both sides. Okay? I want to get a formula that connects R and H. So square both sides of equation 3, I'm having R squared equals to u of x root of 2h all over g all squared. From one of the laws of indices, if I have a b raised to power x, okay, if I open the bracket, this x will affect a, this x will affect what now? B. Will now be having a raised to power x, b raised to the power of what now? Of x. The same thing applies here. Our r squared will be equals to u of x all squared. You see that? Because this one is what now? Product. So we have u of x all squared. Then the root of 2h all over g all squared. Root, you cancel square. This and this will work. So if we move further, we are going to be having r squared equal to u of x all squared dot 2h all over g. Let's multiply. We are having our what now? Our gr squared equals to u of x all squared dot what now? 2h. Let h stand alone. I want h to stand alone. So what will I do? I will divide 2 by 2 u of x all squared. Okay? So this will cancel out this will cancel out this. So what is that the formula that connects height of the tower with the horizontal distance covered, the range? Our h is equal to, from that place, our h is equal to plus gr squared 2u squared. Don't forget, we are still dividing both sides like this. So it will be what now? G r squared, dr squared all over 2u of x all squared. So this is a special formula that connects what now? The height of the tower with the horizontal distance covered. We now have all these formulas under case 1. So let us combine all the formulas together. If you are still enjoying this video, you have learned one or two things in this video. What are you waiting for? Can you subscribe to our YouTube channel? We are on the mission to have 1,000 subscribers. We need you as well. You need us. So can you subscribe to the YouTube channel? Click the red subscribe button. Turn on the bell notification icon. So when we release videos like this, you'll be among the first set of people to get notified. And again, for physical classes, online classes, SS1 to SS3, bio classes, JUPEB, JAM, year 1 university student and polytechnic student. If you need coaching, physical coaching and online coaching, kindly go to the description of this video. You will see our WhatsApp what now group link. Click on the link and that thing will lead you to do what now? To join our group. When you join the group, you can call the two numbers, two admins. You can call any of the two numbers. You pick it up and you listen with them. Subscribe, like the video, comment and share the link. This year is our year. We are going to make it together. Okay? Let us continue. Now, let's get everything together now. So we have how many equations under what? This is equation what now? Equation 4, I suppose. So we have 4 equations under this. So the first one is our what now? Our height, our age equals what now? RGT squared. What is the one? Time taking. We have what now? The root of 2h all over what now? All over g. What is the third one? The range. We have our range equals what now? Ux. The root of what now? 2h all over what? All over g. Then the last one, we have our h equals to our gr squared all over 2u of x all squared. Okay? So let us solve what? Question. Let's solve. Alright, so let us solve some questions that we have on the marker board. The first question is: a stone is projected horizontally from the top of the tower with a speed of 5 meters per second. Class, take note of this. We have projectile, vertical projection, we have horizontal projection, and we have projection at an angle of what now? Theta to the horizontal, which we call inclined projection. So the way we interpret the questions to be solved is very important. So when you get what? A stone is projected horizontally with a speed. This speed given is what now? Horizontal speed. When you see a stone is projected vertically with a speed, that is what now? Vertical what now? Vertical speed. But here, because it is what? Horizontally, it means this 5 is our u of x. So solution question 1, our u of x, which is what now? Horizontal velocity is equal to what? 5 meters per second. It lands on the ground level at a horizontal distance. You see, what is horizontal distance? That is the range. That distance covered is the range. So our range is equal to what now? What is it? 20 meters. That's how we should what? Calculate the height of the tower. This is why question 992. So we have our h equals to what now? On but if you look at this question very well, it is just what now? Relation between what now? Between r and h. Okay, which is the formula? H equals to what now? Gr squared over what? 2us all squared. So I'll just say what? My h equals to what now? Gr squared all over 2 u of x all square. So impute our g is 10 times our r is what now 20 all square, meaning 20 times what now 20 all over 2 times what's our u of x? U of x is 5 all square, that will be 5 times what now 5. I need to cancel? Yes. 2 here 1, 2 here 10, 5 here 1, 5 here 2, 5 here 1, 5 here 4. 10 times 4 is 40. 40 times 2 is equals to what now? 80 meters. So the height of the tower equals to what now? 80 meters. Using what? This formula. This formula. Relationship between what now? H and G. Relationship between H and R. Question number 1, gone. Then question 2. Look at this question. Look at this question. Now says an object R leaves a platform XY with horizontal velocity of 7 meters per second and lands at Q from here, lands here. If it takes the same object 0.3 seconds to fall freely from Y to P, or Y is here, Y is here, Y to P. Are you with me? The obvious moves from what now? Leave this place out, but from X, Y is here, Y is here in the person, Y is here, this point. So X, Y, this is a plane, X, Y, this is the plane. From this out, down to this place, with horizontal velocity of what? Of 7 meters per second, and lands at Q. It takes the same object to fall freely from Y to P, 0.3 seconds. Calculate the distance PR. PQ is the horizontal distance covered, which is our what now? Our range. Okay? And mind you, we said question 2. What is the formula for horizontal distance covered? Range equals to what? Horizontal component of the velocity times what now? Time of flight. Horizontal component of the velocity times time of flight. And this time of flight is what now? Total time spent by the body. And mind you, I told you that the time you take the body to move from this place to this place is the same to take the body to move from what now? From this place to this place. Are you with me? Which is what now? Under what now? Air resistance. When we neglect what now? Air resistance. Negligible. When we neglect air resistance, the time from this place to this place is the same as from here to here. So what do we have to find? 0.3. Are you with me? 0.3. So because the time from this place to this place is given as 0.3 seconds. Okay? It means the time from this place to this place will be just what now? 0.3 seconds. Because they are going to use the same time under what now? Air resistance. So we have U of X is what? 7. 7 times is 0.1 3. This will give us about 2.1 meters. This question is by 1990. 1990. So we've done that. Then the third one, a ball is projected horizontally from the top of a tower 45 meters high with a speed of 2 meters per second. We have been asked to find what now? The time of flight. Time of flight, like I said, is total time spent by a projectile during the course of its motion. So let me write this one off. Question 1 and 2 gone. Let's write this piece off. So let us write the parameter given. We're given what now? H as 45 meters. Okay? We're given the speed U of X, horizontally, U of X. So we have our U of X to give us what? 2 meters per second. What again? Nothing. We're now find what now? Time of flight. So what's our time of flight? Time of flight equals to what? The root of the seat 2 ratio over what? Over G. As simple as that. So now we're having root of 2 times what our H? 5 all over our g is 10. So we have 10 here. This is root of 90 over 10. 0 plus 0. We have root of what now? 9. And what's root of 9? Is what? 3 seconds. That is time of flight, which is time from see that from this place to this place. Okay? Our u of x is 2 meters per second. So time from this place is 3 seconds. So the next one is what now? Horizontal distance covered. That is the range. Which is equal to what? U of x times what now? Time of flight. What are u of x? 2. What are time of flight? 3. So this is equal to what now? 6 what? 6 meters. So let's have one question. Alright, so let us take case 2. Okay? Case 2 is a case where we have the body being projected from the top of the tower vertically at an angle. So we have the structure like this. Okay, let us pay maximum attention here. This is tower. The body is now projected like this. Are you with me? Like this. At an angle of theta. So we have our u here. Our u is here. Angle of theta is here. Are you with me? So this is our what now? U of x, obviously. This is our what now? U of y. Okay? At point t equals to 0, point of projection, we have u of x, we have u of y. Then this point, let us call it our what now? Our h. Big h. From here to here, our big h. Then from here to here, you see the height of the what now? Height of the tower. Okay? Height of the tower. This one is a special case. Okay? Of case what now? This one. Now mind you, from here to here, you see our what now? Our h. Same thing. H is here. This is okay. Same length. From here to here is what now? It's our h. Now, suppose I call this point A. I call this point B. I call this point C. The body is projected from this point down to this place. This diagram is in 2 phases. I can break the motion of this diagram into 2 phases. The first phase is from this place to this place, which is vertical projection. And from here to here is horizontal projection, which is the one that I did earlier. Meaning, we assume that the body is just being dropped horizontally from this place to this place. So I can break this diagram into 2 phases. The first one is, look at this, vertical projection. Vertical projection. Okay, break it down. I have this diagram like this from A to B. A to B will be like this. Just look at what I want to do. A to B will be like this. Okay? So this is our what now? Our B. This is our what? Our H. This is our what now? Our U. This is our U of X. This is our angle of what now? Of projection. This is our what now? Our U of Y. U of Y is what now? Vertical component of the initial velocity. U of X is the what now? Horizontal component of the initial velocity. So from here, that's the first phase, vertical projection. So let us go. Alright. Now, this vertical projection is from A to B. A to B. A to B. So what happens here? We see the curve that our U of Y equals to U sin theta. Okay, I have the link of the first video in this work now. Description box below. Go and watch the first video. So not everything. But the first video under projector, this is the third part under what projector. So our U of X is U cos theta. Now, we'll be required to find the time taking from A to C by this body, which is the time of flight. Time taken by this body from A to C is the time of flight. But that time of flight is broken down into two phases. The time to take the body to move from A to B plus the time to take the body to move from what now? B to C. Meaning vertical projection first, time taken to reach the maximum height, vertical projection. Then time taken from this height down to this page, which is what now? Horizontal projection, which is time for horizontal what now? Projection. So let us go. Now for this one, this body is moving what now? Upward. Yeah, we have, you see, remember our what now? Our V equals to U plus what now? AT. See, remember? Equals to U plus AT. Because we are discussing vertical projection, we have our V of Y will be equals to U of Y, okay, plus A of YT. The body is projected upward, moving against gravity. So our A of Y will go to what? Minus G. So here we have our A of Y equals to what? Minus G. The body is projected upward, moving against what now? Gravity. So it implies this one becomes V of Y equals to U of Y minus GT. Okay, this T is time from what now? A to B. So I can put what here? A, B. Time A to B. Now, class, as this body gets to the maximum height here, this maximum height, the final velocity will be equals to 0. As the body is being thrown upward, the velocity will work now, reducing, decreasing. When it gets to maximum height, the body will stop momentarily before it comes down. So at that point of stop, momentary stop, our V of Y is equal to what now? Is 0. So it means at maximum height, the final velocity reached by the body projected vertically upward equals to what now? Is 0. So here, at maximum height, take note of this, so it's very important to our V of Y equals to what now? Is 0. So this one becomes 0 equals to U of Y minus GT AB. Time from A to B. So I'll come here. We have GT AB equals to what now? U of Y. So what's our GT AB? GT AB equals to what now? U of Y all over what? All over G. Take note of this for me. So where this time is time taken by the body to move from what now? Point A to point B. I assume this is vertical projection. Do you see it? That is the reason why I have to break it down. A to B is vertical projection. B to C is horizontal projection. So they combine two types of projection. Vertical from A to B, horizontal from B. So we've gotten the time it will take the body to move from A to B, which is what now? U Y over what? Over T. I call this equation what now? But recall, U of Y equals to U sin. So this equation can also be in this form. Our T A B equals to what? U sin theta all over G. Put it in block form. Equation what now? 2. Let's now go to the what? The second part, which is horizontal what? Horizontal projection. So horizontal projection. Our horizontal projection will be like this. Look at this very well. Class. Look at it very well. So I have this, something like this. Horizontal projection. So at this point, this body will have U of X. At this point, U of Y because what now? 0. Or let's say V of Y, anyway, equals to 0. So at the highest point, our partial velocity equals to 1, equals to 0. So only U of X is applicable here. Horizontal velocity is the only one at the maximum height. So at this point, I still have my what now? My U of X, which is similar to what we just did first, case 1. But the only difference is this: from here to here is now what now? H plus H. Do you see that? The one we did earlier was just what now? Small h. But here, from this place to this place now, it will be H plus H. Look at it. That. Look at it. That. From here to here, the whole length is this H, maximum height, and the height of the what now? Height of the tower. We have H plus H there. Then this is point B, and this is point C. This is point B, and this is point what now? Point C. So let us get the time. And you take the body from B to C. You see the column that we have our what now? Our x equals to what now? Ut plus half at squared. This x now become h plus h. So we have h plus h here equals to u of x, vertical plane, it's coming down, vertical plane. We have our u of y t plus half at squared. Are you with me? So what's now the next thing? Because it's coming down, vertical. We have what? A of y. Let us forget a of y. U of y at this place, like we said, equals to what now? 0. At this point, our u of y equals to what now? 0. So now we are having h plus h equals to 0 times t is 0. So we have half. Now, our a of y, what is coming down? That is plus g. So we have what now? Gt squared. So h plus h equals to what? Gt squared. Where this h is the maximum height reached by the body. Then this small h is the height of the tower. You can see it here. Height of the tower. So what's now the next thing? Let us put this one in log form too. The formula here. But that's not what we're doing. It's very important that we put this in log form. Let's call this equation 1 and equation 1. So allow us to find what now? The time. This time is time B to C. How are we looking for? So now that we cross multiply, we have our dt squared equals to 2 bracket h plus h. So make t squared square formula. We have our t squared equals to divided by g. 2 bracket h plus h all over g. What's our t? Only t. This t is what now? TBC. TBC now because to the root of 2 bracket h plus h all over g. So we put it in block form. So this is time taking. Time taking by the body to move from what now? B to C. Root of twice the sum of the two heights all over what now? Acceleration of it for due to gravity. So we call this equation what now? Equation 1. Equation 3. I'm taking my time to put all this in block form. But you understand the concept very, very well. Equation 3. This is h plus h. H plus h. Big H plus small h. What's that total time taken from A to C? You ask us to calculate that. Calculate the total time spent by the body during the course of its motion. That time spent by the body during the course of its motion is from A to C, but it passes through B. Okay, so it will go from A to B first to spend one time, then B to C another time. So the time from A to B is this or this, and time from what now? B to C is this. So when you combine the whole time, the time spent by the body during the course of its motion will be equal to, let me write this one off. So the time spent by the body during the course of its motion will be equal to what? Total time equals to what? T of A to B plus T of B to C, and that will give us what? U of y all over what now? All over G plus root of twice the sum of heights all over what now? All over G. You can have it like this, or you can change it to what now? U sin theta. So you can have what? U sin theta all over G plus the root of 2 brackets H plus H all over G. So this is a block form, meaning it's very important. Important in block form. This is block form. So we have that. That is pattern spent by the body during the course of its motion. Okay? So yeah, we can now be asked to find what now? Horizontal distance cover. I'll find the diagram off. And I need the diagram. Horizontal distance cover. That is what now? The product of the horizontal component of the velocity and the sign of light, which is this one. Sign of light is this one. So the answer of page range is very easy. Our range is always equals to what? Your first time what now? Time of flight. Okay? So we use this time of flight there. Then multiply by what now? By our horizontal distance, horizontal velocity given. Okay? Horizontal velocity given. So as is that one. Let us solve some question. But before we solve question, okay? Let us try and get the maximum height here. This big H, maximum height reached by the body during vertical work now projection. And you see we recall that our work now from our V square equals to U square plus 2AX. Now, since we're discussing vertical, because you can also calculate what now? Maximum height. Maximum height. So here, now we having V of y all square vertical equals to what now? U of y all square vertical plus 2A. That become what? H. Am I this one is what? A of what? A of y. Okay? The one is going upward. This our A of y because of minus. Let me write this one. See very well. Let me write this one. You see it very well. Let me write this. So you can see it very well. I hope you are still seeing me. You can see my face, right? So this is my real face. This is my real face. So we have our what now? Our V of y all squared equals to what? U of y all squared plus 2G A of y. The what now? Our H. I'm going to calculate. Then what happened? Our A of y is what now? Minus G. A of y is minus G. So now that means our V of y all squared equals to what? U of y all squared minus 2GH. What happens at maximum height? Final distance to what now? Is 0. Okay? So now that means 0 equals to what now? U of y all squared minus 2GH. So what's our H? This one will come here. Okay? This one will come here. So we have our what? 2GH equals to what? This one is coming here, becomes positive. So U of y all squared. Everything. So let us see. What's now the next thing? We divide this by what now? By 2G. This is our H, which is the maximum height. This H here is equals to U of y all squared all over 2G. This formula 2 is very important. Make sure you pause the video and write all the formulas down. Okay? Write all the formulas down. So, here, mind you, our U of y is U sin theta. I think you know that. If anybody say my H, so my H equals to U sin theta all square all over 2G, which is equals to what now? U square, if I open the bracket, U square sin square theta all over what now? 2G. So finally, I have what now? The height is equals to U square sin square theta all over 2G. So at this junction, let us solve questions. So let us take these two questions, both from JAM questions. So JAM student, YX student, JUPEP student, questions under projectile, you cannot escape there. You can't. So it's better for you to make sure you watch all the videos. This is part 3, like I told you. Watch part 1, watch part 2, watch part 3. If you can watch part 1 to 3, then it means your projectile is what now? Is superb. Okay? It's superb. So let us just solve these 2 questions. Let us solve some questions. The first one is a small metal ball is thrown vertically upwards from the top of a tower with an initial velocity of 20 meters per second. So I have this small metal ball here. It is thrown vertically upward. The motion will be like this. Okay? What is the vertical component of the velocity, which is 20? U of y. I told you when you get vertically upward. This 20 is what now? U of y, not ordinary u. So what about u of y? U of y. U of y equals what? 20 meters per second. Another thing, if the ball took a total of 6 seconds to reach the ground, determine the height of the tower. Where is the tower? This is the tower. So we have from here to here. This is what now? This is height. H of the tower. Mind you, we have this point to this point as the mid H, which is the maximum height reached by the body. Anytime you want to solve questions like this, the best approach is to label for simplicity. So I'll label the point, point A, point B, and point what now? Point C. We're given from here, point A to point C, time A to C is given as what now? 6 what? Seconds. Which is total time spent by the body. Mind you, this space too is see our what now? Our age. This space is our what? Our age. Everything. I want to calculate the height of the tower. This space. Okay? So the formula is what now? Age plus age. See, remember, is equals to what now? R D T squared. What is this T? This T is what now? B C. The time spent from what? From B to C. Okay? Because this H plus H, from here to here, is a function of this second word now, phase of the motion. From here to here is what now? Vertical. Here to here is what now? Horizontal. So this H plus H is a function of this part. Are you with me? Let me bring it out. What I'm saying is this. I have like this. Here is now like what now? H plus H. So the time will have the time from what now? B to C. Are you with me? So don't make mistake. Oh. It's from what now? B to C. So the time I'm going to use for calculation will be time from B to C. Let me get time from A to B. Remove from what now? From the 6. I'll get time from B to C. Let me get time from what now? A to what now? A to B. Time A to B, you can see it correct? Vertical projection. We have our what now? Time A to B equals to what now? U of y all over what now? All over G. Vertical projection. So what do we have here? We have 20 all over 10. This equals what now? 2 seconds. So time spent by the body from point A, this is point A, please oh, this is point A oh, point A to point B is 2 seconds. So what is point B to point C? That would be what now? 6 seconds minus, because time AC equals time AB plus time BC. Are you kidding? Time A to C, AC equals time A to B vertical plane plus B to C horizontal plane, as discussed in what now? In the earlier what now? Explanation. So what do we have here? Our 6 seconds equals to 2 seconds plus what now? Time BC. What about time BC? Time BC because what now? 6 minus what now? Minus 2. That was what now? 4 what? 4 seconds. So the time that I need is B to C, which is what now? 4 seconds. This question is jam 91, you can see it. So what is my h here? This one is make this h formula. This one will come to the side. Now that means our h is equals to what now? RGT square BC minus what now? Big H. So I need the big H. I need the big H. What is this big H? Maximum I attain. That and what is the maximum I attain? The formula of big H is equal to uy all squared all over 2g. Now, class, if question does not involve angle, we use all these ones. Are you with me? But when it involves angle, to be sine and whatever. So here, now that being equals to u of y is 20. So all squared, you have 20 times 20 all over 2 times 10. So what is happening here? 0 cancel 0. This one cancel this. We have 20 meters. So our h, big h, is 20 meters. So we are let us substitute. That's all. Substitute. Now then more half times g is 10 times our TB is what now? BC is 4. 4 squared. We have 4 times 4. Minus what our big h? Our big h is what now? Is 20. What can go here? 2 here 1, 2 here 2. 2 times 4 that's 8. 8 times 10 is what now? Is 80. So I'm having 80. And what now? 20. So our answer will be equal to 60 meters. So the height of the tower is what now? 60 meters. Okay? But the height from this place to this place will be h plus h. We are not asked to calculate h plus h. That height will be what now? Our big h 20. Our small h 60. How was 80? Okay, this place to this place 80. We are asked to calculate this place to this place. So answer is 60 meters. Let's go to question 2. Question 2. An object is collected from a height 8 meters above the ground with a velocity of what now? 40 meters per second. Now, class, whenever you are asked to use u of y, they will say it in the formula. If it's u of x, you say it in the formula. See the way they will say it. They will say projected with horizontal velocity of maybe 20 meters per second. So this one is what now? U of x. If they say projected what now? Vertical velocity. Vertical velocity. This is horizontal velocity. When they say vertical velocity, it means our u of y. Horizontal u of x. Vertical u of what now? Y. But when they say with a velocity, that's our u. Are you with me? Look at this question here. The first one here. Vertically upward from the top of the tower with an initial velocity. This one is what now? Our u of y. Vertical. What's the measure of vertical here? So this velocity is what now? U of y. That's the way they want to trick students. Okay? But once they remain silent, here, it said above the ground with a velocity of what now? 40 meters per second. That's our u. They didn't say horizontal, they didn't say what now? Vertical. Just measure what now? Velocity. That's our what now? Initial velocity, which is u. Are you with me? So let us take the diagram. Let us take the diagram. Same concept. I just want to clarify that thing because students used to use what now? When to use u, when to use u of x, when to use what now? U of y. For u of x, you will see horizontal velocity. For u of y, you will see vertical velocity. But when they say velocity, that is our what? Our u. That's our, it's as simple as that. Okay, so let's go here. Alright, so another is related from a height 80 meters above the ground. So it means in this case, our h is given as what now? 80. I'm supposed to use this diagram. Above the ground with a velocity of what now? 40 meters per second. So our u, this is our u. Our u is now what now? 40. Our u is 40. U is 40. What's the angle of inclination? Angle of what now? Angle of 30 degrees. So we have to find what's the time of flight. Time taken from A to C is time of flight. So we have time from A to B. That one is what now? U of y all over what now? G. And mind you, this one involves angle. To now be what now? use sin theta all over what now g. The first one we solve was not involve angle. That was why we just use ordinary this one, way of y straight. This one involves angle. So we're going to find what now? The partial component, which is u of what now? U sin theta all over g. So what do I have? Our e is what? D times sin what? 30 all over what now? All over 10. Sin 30 is what now? Half. So now we are having 40 times half all over what now? 10. So we give us what now? 20. 20 all over this will give us what now? 2. So having 20 all over 10. And that will give us what? 2 seconds. So time AB is 2 seconds. Time AB is what now? 2 seconds. So I need time from B to C. You see it correct? Time BC, time BC. We calculate time BC. We use our H plus H equals what now? RGT squared. And this is not what now? Our BC. See correct this formula? See correct? So our H is this 80, small h. So we need what now? Big H. Big H. Are you with me? We need this big H. So let us go for the big H. We are having our big H. You can see correct. That's what now? U of y squared all over what now? 2g. Isn't it? So that will have what now? U sin theta all squared all over what now? 2g. So now our u is 40. So about 40 times what sin theta? Sin 30. Everything over what now? All squared all over 2 times 10. So what do we have in class? We have 40 times what now? All over 2 all squared all over what now? 20. So what do we have here? This will be 20. Okay? So we have 20 here times g. 40 all squared all over 2 times 40. So here for 20 all squared here and g. So we are now having what now? 20 times 20 all over what now? 20. So what do I have here? As our what now? Our age. Look at what I did do. This one 1, this one 20. Now after 20 what now? All squared. All squared. All squared. So what is the next thing? 20 times 20. So this one cancel out this one cancel out this. So it means our maximum flight age is 20 what? 20 meters. We're almost there. We're almost there. So we're almost there. So we're done. We're done. So what's the next thing? We must be tilt. Tilt. Now we have been, yeah, let's go. H is now what now? Big H 20. So we have 20 plus what our small h? 80 equals to what? Half times what our G? Our G is 10. Then T of BC all squared. We're looking for what now? TBC. After we've gotten TBC, we now add to what now? TAB. To what total time spent by the body. Total time spent by the body is what now? Time from A to C. Are you getting me? But the time TA is this 2 seconds. We are trying to get time what now? TBC from B to C. So time from A to B plus time from B to C is total time spent by the body. So what is here? 100 because what now? Here we are here what now? 5. So we have 5 TB all squared. So what let's see? Divide this by what now? By 5. By 5. By 5. So we have TBC all squared equals to what now? 20. What is TBC? That will be root of what now? 20. Root of 20 will give us what now? Root of 4 times 5, which will be what now? 2 to 5 seconds. What's the total time? Total time will now give us what? Our 2 plus 2 to 5 seconds. 2 plus 2 to 5 seconds. So we have this. We have this. Total time spent by the body will be equals to what I said as time from B to C, from A to C, other time from A to C because to time from A to B plus time from B to C. So with that time spent by the body. What is A to B? That is 2 seconds. What is time from B to C? As is what now? Plus 2 5 what now? 6. So everything now we can factor 2 out. Now we have 1 plus what? 5 7. So this total time spent by the body from A to C. Subscribe. If you learned something in this video, you've gained something new in this video. Kindly subscribe to our YouTube channel. Like, comment. If there's anything that you want us to do, any video that you want us to do, produce for you, put it in the what now? Comments box below, and share the video with your friends. If you need any tutorial for the PEP, for JAM, SS1 to SS3, IJMB, Year 1 student University and Polytechnic, physical classes and online classes, just go to the comment section below. You will see a WhatsApp group link. Click on the link and join our group. From there, you can contact any of the 2 numbers as the admin there. Okay? If you've enjoyed this video, don't forget to subscribe. We are on a mission of getting 1,000 subscribers. Okay? We want to cover the whole nation. Okay? We need you as you equally need us. This is Shamil Allah signing out. God bless you.